the students are also curious on your entrepreneurial journey, on how
Mm.
you ended up creating Amutri.
Absolutely. Yeah. So I spent the best parts of the last 2 decades building 3D visualization and simulation capabilities across various industries, including aviation, Formula One, architectural design, and automotive. And the list kind of goes on. And I just sort of realized how powerful 3D visualization and simulation is in the design, marketing, and sale of the world around us, but also just how difficult the technology is to adopt by many organizations. So, really on a mission here at Amutri to lower the entry points to 3D visualization and all of its vast benefits. Okay, so we'll just start off with the sort of 3D visualization and why it's important. So, 3D visualization really forms a crucial part of the design, marketing, and sale of the world around us, including new buildings, products, and even services. 3D visualization really enables us to experience and communicate something yet to exist and create complete understanding through interaction. So it helps us to express ideas clearly and understandably. It also helps to validate designs and fix errors before construction and production. It also improves our chances of winning contracts with professional presentations, and the use of engaging experiences of products and buildings can increase sales by up to 23%. So 3D visualizations can be shared in many different ways through many different mediums. For example, they can be shared through traditional imagery or video, as well as web-based experiences, where viewers can explore and interact with the design. In many cases, these may be 360-degree or WebGL style experiences that you might see on a real estate website or a products configurator. And more recently, visualizations can be viewed in virtual reality for an immersive one-to-one scale experience. So there are many ways to showcase designs to clients and stakeholders using 3D visualization technology. So in terms of sort of current 3D visualization trends, we're seeing that sort of photorealistic imagery is still the most sort of frequent way of communicating a design. This typically includes still images and video of new buildings and new products. We've also seen a ton of products and real estate configurators leveraging the power of WebGL, for example. And more recently, we're seeing interactive experiences such as 360 style interactive walkthroughs have become more popular in the communication of designs to clients and stakeholders. So these are the sort of the Google Street View style experiences that you might see online, which are commonly used for kind of more real estate type presentation. So these experiences can be desktop based, mobile, or even virtual reality experiences. And let's not forget the traditional approach of using physical models to present designs. And these can be presented sort of 3D printed to provide even more of a sort of a tactile presentation experience. So in terms of the 3D visualization process and how organizations and 3D artists and designers go about creating 3D visualizations, most 3D visualizations that are produced as part of the design, marketing, and sale of the world around us are derived from CAD and BIM files. And more recently, we're seeing more of an emphasis on BIM data. So in many cases, these are created by teams of highly skilled 3D visualizers and artists who turn this data into visually rich imagery and experiences. So this is a complex and time-consuming process that can take months to learn and even years to master. From a very high level, the 3D visualization process starts with a CAD or BIM file and is prepared using 3D modeling software such as CDS Max, Blender, or Maya. And eventually, these files are prepared and then imported or sent to a rendering solution such as V-Ray, Octane, or Cycles for presentation to stakeholders and clients. So this is a really sort of painstaking process with days or even weeks spent preparing and rendering CAD and BIM files, with most of the time spent preparing and rendering content. So specifically, if we look at the preparation process, this can involve things such as fixing of CAD and BIM geometry, the fixing of face normals, redundant objects removal, and the removal of redundant materials, and even the UV mapping of 3D geometry. And this is before you even get started with textures, materials, and lights. All these elements are required to produce compelling 3D visualizations. And we've spoken to countless organizations and people who are struggling with this step, especially when needing to prepare hundreds, if not thousands, of CAD files per month for presentation to clients. So as an example of this problem, we can see a common issue with CAD files on the left. So typically these CAD files come with quite extreme issues when it comes to geometry, such as normal smooth angles are incorrect and face normals are the wrong direction, and geometry is just generally really unclean. We've also got a ton of redundant and extra materials that are not actually required for rendering. So during the model preparation process, we must ensure that face normals are all facing the correct direction with appropriate face smoothing values. Models don't include redundant or duplicate materials and objects or overlapping faces and degenerate geometry, but do include uniform and complete UV mapping. So it is a really sort of painstaking process to take a CAD file and prepare it for 3D visualization with nice clean model topology and sort of face normals all pointing in the correct direction. So we can see here an example of issues with UV mapping as well. So on the left, we have a pretty badly UV mapped CAD file. On the right, we have a nice, clean, uniform UV map. So this can take a few hours to unwrap by a 3D artist. And the important thing with UV maps is that they really need to be sort of clean, uniform, and ultimately the right scale to enable textures and materials to be depicted correctly to end users, essentially. So it's usually the job of a 3D artist to take these complex CAD files and prepare them for 3D visualization, which can result in weeks, days, or even months of work in extreme situations, especially when dealing with multiple file formats and design iterations from architects and designers. So the final result of this work, with the addition of textures, materials, and lights, is a final presentation, a visualization, in this example, in the Unreal Engine, which is well optimized, it's defect-free, it appears realistic and convincing, and it's compelling to the viewer. So this can be shared via an online interactive experience, imagery, video, and desktop experiences, or even virtual reality if you want to. So just to focus back in on the preparation process one more time, I'd like to introduce our first product. It's called Amutri Fix, and this really takes care of the lengthy CAD and BIM file preparation process, meaning that teams can get to rendering in minutes rather than days or even weeks. It supports a wide range of native and common interchange formats from CAD and BIM through a simple upload, process, and download user interface, which takes care of the fixing of CAD and BIM geometry, the sorting out and flipping of face normals. It fixes the issue of sort of duplicate and redundant materials and objects, and it also even UV maps geometry for us as well. So from here, our users can take the resulting 3D visualization ready files into their 3D modeling and rendering software of choice, enabling them to focus on the interesting parts of 3D visualization and automate the laborious, mundane, and time-consuming parts. And I'll just go ahead and demonstrate Amutri Fix now. So you can see here a quick demonstration. So typically CAD files include a lot of unnecessary components for visualization, such as interior objects, which are not actually seen during rendering, along with extremely complex geometry that can take hours or even days to prepare for visualization. This is where Amutri Fix comes in. Amutri Fix is able to prepare these complex models for visualization in just seconds using a novel web service that automates the optimization and cleanup of CAD data. So users simply upload their CAD files in either native or common interchange formats, and Amutri Fix does a hard work of model optimization, the fix of normal directions, UV mapping, and material cleanup, such as the removal of redundant materials. And then we can just simply download this model, import it into our 3D modeling package of choice, in this case 3ds Max, and then we can go ahead and render it. So we'll have to just wait a few seconds for the file to be prepared. So in this situation, the model is being prepared in terms of geometry. So we're looking at the topology, we're sort of cleaning that up. We're filling sort of holes, as well as sort of holes in the geometry. We're also welding sort of vertices and just making sure that the model is nice and watertight and ready for 3D visualization. Right now, it's been UV mapped so that we can start to depict textures and materials correctly on the 3D model. And the next step will be the fixing of normals. So this just means that we don't have to get into each face in 3ds Max and fix it manually. So we can see here, this is the resulting model in 3ds Max. It's nice and clean in terms of geometry. There's no craziness when it comes to normal direction. And if we just look at the edges, we can see we've got nice, clean watertight and uniform geometry. And then in a second, we can just go ahead and have a look at the UV coordinates as well. So we'll see that these are nice and uniform. You can see we've got nice sort of clean flowing UV coordinates ready for texture application as well. So this just really gets us to a point of having a 3D visualization ready model in just a few seconds, enabling us to go straight into rendering without having to deal with the complexity of model fixing, normal fixing, and UV mapping before the rendering process, essentially. Okay, so that's Amutri Fix. So next, I would like to introduce Amutri Render. And this is a revolutionary product that automates the entire process of preparing, rendering, and presenting CAD and BIM files, and it does this in just a few seconds. So ultimately, Amutri Render turns CAD and BIM files into high-quality, web-based 3D visualizations in just a few seconds. It supports a wide range of CAD and BIM file formats, including IFC, DXF, DWG, and even Revit files. It really enables users to communicate the designs to stakeholders and clients in just a few seconds, and is ultimately designed to support stage 2 and stage 3 of the REBA plan of work, which is spatial coordination and conceptual design. So let's go ahead and demonstrate Amutri Render now. So I'll just take you through the end-to-end process of creating a visualization. So this is really the fastest way to create a real-time rendered web-based 3D visualization. So we're using a Revit file, inclusive of geometry and materials such as glass, concrete, and metal. And here's an example of that file now. So we'll go ahead and sign into Amutri. And here we can drag and drop a file. And I'll be using the Revit file that I just showed you, which is here. If we just drag and drop this into Amutri, we can simply go ahead and upload and process the file into a format suitable for 3D visualization. So Amutri is now working through the file and fixing any issues with geometry to make sure the resultant experience looks great. And this just takes a few seconds. And now we can go ahead and start the experience. Amutri will now apply all of the elements you'd expect to see in a 3D visualization, such as textures, materials, and lights. And now we can start to explore our CAD file. Moving around is made simple through intuitive mouse controls, combined with keyboard controls. And if we'd like to, we can adjust the time of day as well. I'll take a high resolution screenshot of the model. Okay, so let's just jump into the experience now. And I'll just have a speed a little bit just so I can move towards the building a little bit faster. And I'll just move over to the far corner of the building. Okay, so it looks pretty good to me. And we can go ahead and adjust the time of day a little bit as well. So we can see that this is all real time and all web-based. So the great thing is that this is all cloud-based. This looks pretty good to me. So it's all cloud-based rendering, which means that there's no dependency on local IT hardware. So we can move into the space now and have a look around. So we can see we've got materials and textures and lights already all positioned and placed in here. And we can see that the impacts that the time of day has on these windows and the interior space, if we just adjust the time of day, as well as the rest of the space as well. So if we just move backwards a little bit, we can have a look around. And this is also ultimately the fastest way of converting a CAD or BIM file into a high-quality web-based experience. So we can have a look through here as well. You can see that we've got some nice furnishings that have been imported from our original CAD file. In this case, it's from Revit. And then we can also start to inspect design features, including doors and door widths, for example. So it's a very quick example of how Amutri can turn a CAD and BIM file into a high quality and contextual web-based experience in just a few seconds. And I'd like to just demonstrate one more visualization from Amutri as well. So this gives a little more context due to the original BIM file's additional information. So it has buildings that surround the design, It has additional information when it comes to foliage and interior furnishings as well, which really enables Amutri to render to a much higher quality, inclusive of interior models and light sources. You can see here we've got some real nice ceiling lights that are missing some light into the space as well. We've got some really sort of natural daylight coming through the windows. We've got some nice furnishings placed around the interior space as well. And this is all being created in just a few seconds from CAD data, in this case, Revit again. And we can go ahead and adjust the time of day. So we can just move it to sort of, 8 or 9 p.m. And we can see that this is a really interesting effect on the interior space. So that's looking quite nice. And we can see that the lights have automatically adjusted. And we have a really nice sort of evening-based 3D visualization of this commercial building. Okay, and that's a quick demonstration of Amutri Render as well. We would like to offer event attendees a promotion as well, so you can go ahead and get 50% off Amutri Fix for your first 3 months. And Amutri Render is actually free for your first 7 days as well.
What's the file format?
Yeah,
the demo a while ago.
Yeah, so we support. This is Revit, so it's a Revit file, which is a 3D Revit file, inclusive of textures, materials, and light sources. So the more information that's stored in the original CAD file, the better quality the Amutri render. We are working to improve the quality of the product so that it's less dependent on the contents of the original CAD file. But at this point in time, we pretty much sort of read in textures, materials, light sources, and objects, and we make a best approximation as to what that should look like. And then we render that in the web. So it's all cloud-based. There's no need for local IT hardware. So we render everything for you. There's no need to spend days or weeks learning how to produce 3D visualizations and immersive experiences, because the whole thing's automated from CAD data.
Yeah, I think that's cool. And it really is. I guess the trend nowadays is going on cloud, right? So SaaS.
Exactly, that's right. It's essentially the first SaaS-based 3D visualization products. And the whole point of this is to dramatically lower the entry points to your 3D visualizations. So with Amutri, there's no need to worry about recruiting large teams of 3D artists to crunch through the process of preparing CAD data for 3D visualization. If you want to render that content, you can render it as well. But the whole point of Amutri really is to add speed to the 3D visualization process. I mean, the whole sets of end-to-end from CAD to visualization much faster, much more cost-effective.
Yep. Can you open up once more, Michael, your Amutri once more?
Yeah, absolutely.
Just for the sake of our audience seeing it.
Yeah, certainly.
How it looks like.
Yeah. Let me just share my screen.
So once more, encouraging everyone to ask questions.
Here we go.
Okay. So it really is, as you can see, it's, what's that, Chrome, right?
Yeah, this is in Chrome, that's right. Yeah. So it's all sort of fully sort of real time. We can move around here. We can move outside as well. Here we go. Kind of interesting. We can have a look around here. We can even sort of adjust the time of day so it's night time as well. It's a very sort of quick way of producing a sort of a visualization from CAD data. And this is all using the power of the Unreal Engine. And we've essentially automated the whole process of preparing, fixing, and rendering CAD data for presentation in the Unreal Engine. It's all cloud-based, so yeah, there's no need for expensive IT hardware, and we can just simply upload, convert, and view in just a few seconds. So it's the fastest and most cost-effective way of currently producing 3D visualizations. The more information in the CAD file, the better quality the results as well. So if you've got furnishings in the CAD file, they'll look like this, and we sort of process them and polish them up to look presentable. So we fix geometry and prepare that CAD data for real-time rendering.
I have a question, Michael. So the ones we're seeing, is this coming from Revit, SketchUp, or where was this made initially?
This so in this situation, it's in Revit, but it has been. This is I would class as a really good example of a Revit file in terms of the quality of the furnishings. So this is an example of a high quality Revit file with high quality 3D models in the Revit file. We are working to increase the the intelligence of Amutri so that it starts to be able to plate objects from low quality assets in Revit. But this is it's an example of a high quality, well prepared Revit file essentially.
Okay. So, yep, another question from Chad. Are you seeing this?
Yeah, I can see that. That's correct. Yeah, absolutely. So we support native formats like Revit. We also support common interchange formats as well. And the better the quality of the CAD file, the better the result of the renderer. But ultimately, we do support any CAD file. Absolutely. Yeah.
Any suggested file size?
Mm. Yeah. So I would say typically we're seeing most users upload files of between 50 and sort of 200 megabytes usually. The good thing is that with Amutri, there's no need to worry about sort of materials and textures in the file itself because we apply them on the back end of the products. We just need a model from CAD data with essentially materials applied to that model, and we just need the material names essentially. So as long as it's a 3D model with materials applied, we can take that, apply textures and lights and everything else. So typically file sizes are quite low, but we can pretty much support anything up to a few hundred megabytes if we need to.
If I upload a SketchUp file, so how long does it take
Mm.
for Amutri to give it back to me looking awesome?
Yeah, that should be less than 30 seconds, maybe a minute maximum. So we support SketchUp as a native format. We also support FBX files, so you can export from SketchUp as an FBX into Amutri, and that would take between 45 and 60 seconds to produce a
Really?
visualization.
Can you
That's
show
correct.
that to our audience right now?
I
I
have,
guess
yeah. What I could do is let me just find an example
I
file.
think everyone is curious on how fast it is to convert a simple
Yeah,
file into an awesome render. Let's show it to
let's
them.
try that. Yes, if I just find a test file now, I'll just drag and drop this guy in here. So this is a pretty straightforward IFC file. I'll just upload that. It gets converted in just a few seconds. I can start the 3D experience. So at this point in time, Amutri will start to fix geometry. It will apply UV maps and textures, and obviously materials as well. And in just a few seconds, it will start to stream that to the web browser from our cloud-based system. So we'll give it a few seconds. And you can also, if when using Amutri, if you have a request for a feature, you can just log it in the panel on the right, and we'll receive that information, and we'll build. We can respond to you as well. So if you've got like a particular request for a file format or a feature, just make a suggestion in here. We'll see that, and we'll start to build that out for you.
Lighting function done by Amutri is the lighting.
Yeah, so we are currently working on lighting. So our plan is to be able to understand what sort of lights are placed in CAD files, and then we can place a light source in Amutri based on the information containing that lights, the light source in Revit or AutoCAD or a different sort of modeling package. So yeah, absolutely, we do plan on supporting lighting.
Does the Amutri change the color
Mm.
visualization a little bit compared to Revit, or it rendered the exact same color
Yeah.
visualization?
We do try to represent CAD data as close to the original file as possible. So generally, if there's a concrete material applied, or steel, or copper, or some other material, we try to best match that as close as we can do. So if users do want any sort of editability in, if users do want some sort of editability within the experience itself, we can go ahead and start to sort of introduce the ability to change materials, change material hue, saturation, color, and that sort of thing. That's certainly on its way.
Does it have 3D assets like plants and furnitures available?
Yeah, so we're building a 3D catalog, a catalog of sort of 3D models behind Amutri that we're going to use to essentially automate so the placement of those objects will be automated based on CAD data. So if you've got some seating or some furniture in Revit or in AutoCAD, we'll replace that with a high quality counterparts from a model library. That's currently being built at this point in time. So we're kind of working towards that right now.
Can we use our own texture material from Monte Carlo Yabut?
Yeah, so we've had this request a few times, and we are considering the ability to enable users to upload their own textures and texture libraries to Amutri. So essentially, rather than using our texture library, it would use your own texture library. So absolutely, if you have any specific textures, such as types of leather or concrete or plastics and that sort of thing, we can start to apply them in Amutri as well. So that's certainly something that it hasn't been built yet, but we are really interested in building that feature.
For wayfinding signage, could graphic artwork labels decals be shown in the render?
Yeah, certainly. So if it's contained in, if the base CAD file contains that information, that will be rendered in Amutri automatically. But we could also start to look into interactivity in the experience itself to enable users to place objects in the experience. So you could just drag and drop a model in here and place it, for example, on the wall, or place decals around the space. So again, that's not been built out just yet, but that's perfectly feasible for us to build that out.
It was mentioned that for one-to-one view, this can be viewed in VR. What platforms are needed for the VR? Can
Yeah,
you
so we're
import this to
currently
AR? Yeah.
Yeah, so we're currently working towards VR support. So the plan is to stream this into headsets, self-contained headsets, such as the Oculus Rift S, for example. We haven't yet built out VR support, so it's desktop only at this point in time. But we have built a vision in a way that means that we can eventually support VR devices. When it comes to AR content, we haven't yet considered AR support, but we would love to hear from users who do need augmented reality content for Amutri as well. So absolutely, we'd be really sort of keen to understand the use cases around AR.